Hi everybody, in this video we're going to go over the right triangle altitude theorem. So the right triangle altitude theorem says if the altitude is drawn to the hypotenuse of a right triangle, so let me draw in my altitude to the hypotenuse of this right triangle here. Remember, an altitude is a perpendicular line that passes through the opposite vertex. So if I want the altitude to be drawn to the hypotenuse of the right triangle, the opposite vertex to the hypotenuse, which is AB, would be point C. And we know that altitudes form are perpendicular lines, so they form right angles. So what we have here is we have a big right triangle, the one that we started with, and now from the altitude, we have two smaller right triangles. So what the right triangle altitude theorem says is that if we draw in this altitude to the hypotenuse of our original right triangle, all of the right triangles formed are similar to each other and they're similar to the original triangle. So these two smaller right triangles would be similar to each other and to the bigger right triangle that we started with. And the reason why all those triangles are similar is due to AA. They each have a right angle in them, and we know that all right angles are congruent. And since the smaller triangles are inside of the large right triangle, there is a shared angle. So that gives us our second A for AA by the reflexive property. So what I'm going to do first, since I know that all of the triangles are similar, is I'm just going to name the three similar triangles. And when I name the similar triangles, I want to try to name them with their corresponding parts in order. So I'm just going to redraw the big right triangle. I'm going to just redraw it facing up. So that would be angle C if I flip it up. That would be A, and this would be B. And I'm going to re-put in the altitude that we had. And the reason I'm redrawing the triangles flipped upwards is to make it easier to see what the corresponding parts are. So first I'm going to name the big right triangle when I forgot to put in the right angle at angle C. So I'm going to name the big right triangle CAB. Doesn't matter. Okay. Now when I name the smaller right triangle, I want to put the corresponding parts in order. So I started with C, which is where the right angle was at of the original right triangle. So I want to start with the right angle in this small green triangle, which would be right over here. So I'm going to label that D. Next, we put A. And if you take a look, A is an angle that's in the big right triangle, but it's also an angle in the small green triangle. So it's shared between the big right triangle and the smaller green right triangle. So it's congruent to itself by the reflexive property. Since it's shared between the two triangles, it's going to correspond. So I'm going to put that second, just like I have it second here. And that leaves C to go last in this triangle name. Okay, now I just want to name this last right triangle with the corresponding parts in order. In the other two triangles, I started with the right angle, so I'm going to start with the right angle here as well. Then I went with the shared angle, and between the big right triangle and the smaller red triangle, angle B is the angle that's in common, that's shared between the two of them. And that leaves angle C last. So it's really nice when we're talking about triangles, any kind of triangles, to put corresponding parts in order. That's generally what we do. We put corresponding parts in order when we name triangles. Okay, so now that we have the right triangle altitude theorem, and we know that the two smaller right triangles are similar to each other and to the big right triangle, we know a couple of things. So when we have similar triangles, the corresponding sides are proportional. So we have two rules, the leg rule and the altitude rule, that come from knowing that we have similar triangles. So the leg rule says that each leg of a right triangle is the mean proportional between the whole hypotenuse and the part of the hypotenuse directly below the leg. So mean proportional just means that in the proportion, it gets written twice so that when we cross multiply, it gets multiplied by itself. And the leg of the right triangle is the mean proportional between the whole hypotenuse and the part of the hypotenuse directly below the leg that we're talking about. The altitude rule says that the altitude drawn to the hypotenuse of a right triangle is the mean proportional between each part of the hypotenuse. So once again, mean proportional just means that in the proportion, it gets written twice so that when we cross multiply, it gets multiplied by itself. So in both situations where we need to use the leg rule or the altitude rule, the diagram, the situation will always look the same. You'll always see a big right triangle with an altitude drawn to the hypotenuse. So whenever you see a diagram that looks like this, a big right triangle with an altitude drawn to the hypotenuse, creating the two smaller right triangles, whenever you see this picture, think, am I going to be using the leg rule or the altitude rule? Now, in order to differentiate between whether you're going to use the leg rule or the altitude rule, you need to think about, for the specific question that you have, what are you given and what are you trying to find? If I'm given the altitude, or if I'm trying to find the altitude, then I'm going to go with the altitude rule. If I'm not given anything about the altitude, but instead I'm given something about the leg of the right triangle, or if I need to find the leg, then the leg rule might be the better option. Let's take a look at this example here and figure out leg rule or altitude rule. I know it's going to be one of the two just from looking at the diagram because I see big right triangle with an altitude drawn to the hypotenuse. And if we read the question, it says that the length of AD is 6. So AD is the altitude. We have the altitude. So already in my mind, I'm thinking that we're going to use the altitude rule because we have information about the altitude. It also tells us that the length of DL is 4 times the length of BD, and we're finding BD. So I'm going to represent BD as X, and since DL is 4 times BD, I'm going to represent DL as 4x. So according to the altitude rule says that the altitude, which is 6, is the mean proportional. Remember, that means it gets written twice in your proportion so that it gets multiplied by itself between each part of the hypotenuse. So see how the altitude divides the hypotenuse into two parts? So one of those parts is x, that's BD, and the other part is 4x, that's DL. From here, all we need to do is cross multiply, and then we can solve for x. So when we divide by 4, I have x squared is equal to 9, square root both sides, x is equal to 3. And BD was represented as x, so the length of BD here is 3. Let's do a couple of practice examples. So this first one says the altitude to the hypotenuse of a right triangle. So let me draw a picture. Right triangle, altitude to its hypotenuse. Okay, so it says it divides the hypotenuse in two segments, which I see here. In part A, it says the segments are 5 and 20. And it says to find the altitude. Since we're finding the altitude, in my mind, I'm thinking automatically altitude rule. So I'm going to set up my proportion. The altitude, which I'm finding, is the mean proportional between each part of the hypotenuse. Cross multiply. And we have the altitude is 10. Now in part B, we have a different situation. So I'm going to draw, I don't want to draw a new diagram. I'm just going to reset. I'm going to use red for this for part B, so we know it's a different situation. So this time we're given that the altitude is 8, and the short segment, one of these two segments is 2. And we need to find the long segment. So once again, even though I'm not finding the altitude, I have information about the altitude. So that tells me I'm once again going to be using the altitude rule. And the altitude rule says that the altitude, which is 8 here, is the mean proportional between each part of the hypotenuse. So that's 64 is equal to 2x. So x is equal to 32 when we divide both sides by 2. Okay, here we have another example. Let me just set up my diagram. Once again, it's always the same setup every time. So the hypotenuse of a right triangle is 50. So let me label that. And the short leg is 30. Find the length of the part of the leg directly below the part of the hypotenuse directly below the leg. Typo there. It's supposed to say find the length of the part of the hypotenuse directly below the leg. Okay, so this time it's talking about legs. We're finding the length of the part of the hypotenuse directly below the leg. And we're given that the leg is 30. So that tells me leg rule. So remember, the leg rule says that the leg, which here is 30, is the mean proportional between the whole hypotenuse and the part of the hypotenuse directly below that leg. So here we have 50x is equal to 900. All we have to do here is divide 900 by 50. Let me get my calculator out. And that is 18. I highly recommend that you pause the video and try these two examples for yourself. Okay. The segments formed by the altitudes of the hypotenuse of a right triangle are 8 and 10. Find the length of the shorter leg of that triangle. So it's either this one or this one. I don't know what the shorter leg is going to be, but I know I'm going to be using the leg rule because it's talking about finding lengths of legs. So first I'm going to find x. So the leg rule says that the leg is the mean proportional between the whole hypotenuse and the part of the hypotenuse directly below that leg. Let me cross multiply. 18 times 8 is 144. So this leg over here is 12. Finding the other leg to see if it's shorter, we have, once again, the leg is the mean proportional between the whole hypotenuse and the part of the hypotenuse directly below that leg. And then I have 180 is equal to y squared. And if I take the square root of 180, just to get an idea of what it is, it's approximately 13.4. So 12 is the shorter leg. Okay, moving on to the next one. CD is the altitude to the hypotenuse AB. CD is 6, AD is 3, DB is 5x minus 3. Think about, do you think we'd be using the leg rule or the altitude rule here? If you said that you think we'd be using the altitude rule, you're correct. Because even though we're not finding the altitude, we have information about it. So the altitude rule says that the altitude is the mean proportional between each part of the hypotenuse. So here we have 15x minus 9 is equal to 36. Let me get my calculator out. 36 plus 9 is 45. And divide that by 15. There we go. Please pause the video and try these ones out for yourself. The second one is a bit tricky, but try to at least set up the proportioning and get as far as you can. And then you can unpause the video because I am going to go over them now. Okay, so over here, we're finding the length of RQ. I'm going to label that as X. We have information about the leg of the big right triangle, so that's going to be the leg rule. The leg rule says that the leg of the right triangle is the mean proportional between the whole hypotenuse and the part of the hypotenuse directly below that leg. So here I have 17x is equal to 225 I'm going to divide that by 17. And I got that x is approximately 13.2 because it does say to round to the nearest tenth. RQ is approximately 13.2. Okay, in the next one, we have information about the altitude. So we're going to be using the altitude rule, which says that the altitude is the mean proportional between each part of the hypotenuse. So here we have x squared plus 7x is equal to 144. The highest exponent is 2, so this is a quadratic equation. So I'm going to subtract 144 from both sides to get my equation equal to 0. And now I can solve by factoring. I'm looking for two factors of negative 144 that add up to give me positive 7. So let me write down my parentheses and let me find my factors of negative 144. So I'm getting 16 and 9. So 16 would have to be positive and 9 would have to be negative. And that works. 16 minus 9 is positive 7. So positive 16 and negative 9. We reject the negative because it doesn't make sense for a side of a triangle to be negative. And we have that our x value is 9. If x is 9, that means dB is 9. And that means AD is 9 plus 7, which is 16. So that means the length of AB is 16 plus 9, which is 25 in total. If you didn't remember how to factor, you could also use the quadratic formula, even though I don't like it because there's a lot of plugging in. But quadratic formula can be all put into your calculator as well, and that is given to you on the reference sheet of the Regents exam. Keep in mind that you could have very well have used the quadratic formula if you didn't remember how to factor the way that I factored here by finding the two factors of negative 144 that added to 7.